A great question is, how do I tell someone what values I want to include when I'm talking about a set of numbers? And really, we're talking about intervals in which there's infinite number of numbers. So in all reasonable situations, we can't list out all of the things we want in this interval. So let's talk about notation involved in these intervals. Here's the first example. So in words we're given x is less than or equal to -4. So let's transfer that knowledge onto the number line first. A -4 is a key number here from the sentence, so I'm going to put a mark at -4. And the mark I'm going to put is a solid circle, or a closed circle. And I'm putting that because I want to be equal to -4 and then also some other stuff. So I want to be sure that I'm including -4 in my drawn interval. Now I want x values less than or equal to that. So let's check. If I go to the right, those values are bigger. I don't want those ones. If I go to the left, those ones are smaller. Those satisfy less than or equal to. So here I'm going to draw off to the left and extend with an arrow saying this interval continues on beyond what my picture shows. It's headed toward -infinity, which is not a place, right? It's not an actual number, it's just a goal or an idea. Let's transfer this now into interval notation. Interval notation comes really nicely off a graph. So watch this. We're going to think about intervals in terms of what bounds this set of numbers on the left or on the small side, and what bounds this set of numbers on the right or on the big side. So in this case, let's start on the right. -4 is our upper boundary. And we're including -4 in our interval, so I'm going to use this inclusive square bracket notation. On the left, I don't have a specific boundary, but I'm headed off toward -infinity. That's the best I can do to say a left boundary. So I'm going to say -infinity. And I'm going to put a comma there between the left boundary and the right boundary. On the left here, -infinity, like I said, is not a number, so we can't include the value. We're going to use a parenthesis to say, head in that direction, but don't ever be at -infinity. So that's my interval in interval notation. Using inequality notation next is taking this sentence and translating now with greater than or less than symbols. So we're going to say x is less than or equal to -4. Notice in this case, it really falls nicely from the graph. -4 is on the right, and we have x's to the left of -4, thinking small to big. Set notation is going to borrow from inequality notation, and it's going to use these braces. So there's a left brace. I'll say x such that, this is a vertical line, so again, x such that x is less than or equal to -4, and then I'll close that with a different brace. And I'm going to put that language, x such that, for how we read this. Let's look at another example. So here we are over in a new example. We're given the number line this time. So notice here this green section, and my number line is a number line of t values here. So let's do this in interval notation first. I'm looking at the left edge of my interval and the right edge of my interval. So key numbers to notice on the number line are -3 on the left. That's included because of my solid circle. On the right, I have 2. That's an open circle, so it's not included. So I'm going to use a parenthesis here. If you think about the t values here, really close in here, That's like 1.999, right? That number is an okay number in the interval. But as soon as you get to 2, no way, okay? 2 is out. 2 is not part of this interval. It's just thought of as the boundary on the top or on the big side. In inequality notation, we're going to, again, come off the graph or off the number line and put -3 on the left. We're going to put t in the middle, and we're going to put 2 on the right. Now I'm going to fill in my inequality symbols. So -3 compared to t, well, that's going to be less than t, right, because it's on the left boundary, but t can also be equal to it. And then on the upper side, remember we don't want to include 2, so I'm going to use just a less than symbol. Notice here that as I gaze with my eyes from left to right, I'm moving from small numbers to big numbers. And t is right there in the middle. Set notation here is going to use those braces again. We're going to say t values such that t is between -3 and 2. In words, we'll say t is greater than or equal to -3 and less than 2. So I'm using the left boundary first to talk about t is greater than or equal to that left boundary, and then it's less than 2 or less than that upper boundary. So there is your second example. Let's check out when might we use this skill in our other math class settings. So we might use this skill when we're talking about defining domain and range for a function or relation on a graph. We might note a set of values for which a model is applicable, saying we don't care about negative time, we don't care about negative height, those ideas. We might describe a range in which we want our math grades to be, right? What range of numbers gives me an A in this class? Or maybe defining what temperature a sleeping bag is rated for so that you're safe in your winter camping adventures. Maybe giving a warning about necessary storage requirements for storing medications. And as always, you might use this at a party with your fellow mathematicians.